things are making sense. We had a elk time today that seemed to be pretty productive for folks that stopped by. We've talked about coterminal angles, reference angles. What else did we talk about there? Positive, negative rotations away from something. Why we're doing stuff between 0 and 360 and 0 and 2 pi, and we related everything to radians. And today we're talking about more probably about something that you guys were looking at in your assignment, about reference angles. Okay, and I got even reference triangle up top, and it says evaluating trig functions of non-quadrantal angles. A quadrantal angle have terminal rays on the axes. So a quadrantal angle is like if I'm going to go pi over 2, pi, 3 pi over 2, those would be quadrantal angles because the angle ends on the axis, and I cannot work with a reference triangle because there is no gap between the terminal ray and the axis itself, so I wouldn't have a reference angle. Okay, so what they're talking about here, I'm going to example everything you're doing here, okay, with this as I'm going. I filled some stuff out when I was in back and getting some stuff done, but I want to just talk about the point P and a few things, but I've got sine of negative 210, okay? The sine of negative 210 is the same. What's 360 minus 210? It's like 150, right? So I'm looking at a 150 degree angle. So if I look at this, coming from here, find the following without a calculator. So let's see what we can do with this. If I'm coming around here and I've got this, excuse me, I've stolen something. If I'm coming around here and I take this as 2, okay, and people are like, where did you get 2? I'm just saying it's 2. I don't have a P in there. I'm just putting it out as 2 as my ray. I could have put it as 1 for a ratio, okay? And if I'm looking at negative sine of 210, let's put that in my calculator really quick. Find the following without a calculator. We won't. I'm just kidding. All right. But if I've got negative 210, this is 150 right here. Are you okay with that? Yes or no? If that's negative 210. What's my reference angle? 30. So I got a 30 degree reference angle. If I close this in and make that 2, and make that square root of 3, and make that 1, what type of triangle am I putting around it? 30, 60, 90. And why in the world is this negative square root of 3? Because I'm going left, on my x-axis, because that's where it ended. So what we're talking about with a reference triangle is a triangle that we can use to help us find information based on the reference angle we have coming from the terminal ray in the x-axis. Now, all the information I have here and what you are used to seeing, if this was a 30, 60, 90 triangle, we did 2, 1, and the square root of 3 when you guys were geometry students, okay? Now, today in my elk time, we talked about the fact we'd be using the unit circle. The unit circle is just a circle that has a radius of 1 unit, which would be 1. So you guys are going to see 1, 1/2, square root of 3 over 2 for those ratios when we work with the reference triangle. For today, I'm just going to use my 30, 60, 90 triangle stuff. Are there any questions about what I'm doing and how I set up my reference triangle? And why it was to the left, or why the square root of 3 is the negative square root of 3. So we're okay? Now, based on that, because my sine of negative 210, or my sine of 150, or here my sine of 30, are going to have the same ratio, okay? Except this is negative. So sine is opposite over hypotenuse, so I should have a half coming through here. So opposite over hypotenuse should be a half. As I get this going. Now, your calculus should kick off the same one, okay? And you can check yourself with the calculator, but one of the reasons why we do things without calculators is because you are going to work with exact answers. The square root of 3 over 2, you don't want to round that sucker. You want it as an exact. It's easier to do some stuff with it. So my next one, and we're just saying, hey, what's the answer? This is my answer. I'm done with it. That's the main part. I'm doing this reference triangle to help me out. Okay? Are there any questions about my reference triangle? You doing okay? Next, I got the tangent of 5 pi over 3. First, I must know where 5 pi over 3 is located. Now, 5/3 of a pi, okay? So I've got 1 pi over 3, 2 pi's over 3, 3 pi's over 3, 4 pi's over 3, 5 pi over 3 should be in the ending down here. My reference triangle should be right here with a 60-degree angle left, okay? Now, I know I'm using pi's over 3, but I'm trying to make the transfer from radians to degrees to radians happy for everybody. By the way, 60 degrees is the same as pi over 3. Okay, it's 180 divided by 3. So if I'm going to set up my reference triangle, it's the same triangle I had before with my radiuses being 2, my short side is 1, my longer side, the side opposite my 60 degrees, is square root of 3 over 2. Okay? Or square root of 3, excuse me. But why is it down this time? Remember the orientation of my triangle. Does it make sense that this would be 1 because it's opposite my 30, my 90's here, and I get to go down negative the square root of 3? Are there any questions about my setup of my reference triangle? We're feeling comfortable with that? Because remember, we were working with 5 pi over 3. It goes all the way around from my standard position to end there. We're doing okay? Now, 5 pi over 3 is the same as 300 degrees. Okay, I want you thinking 300 degrees. Now, it's dangerous for me to do this because then you'll go, oh, if it's the same, I can always transfer it from degrees to radians, radians back into degrees. No, be able to work with both. But I want you to have that sense of what it is. Okay, so as I'm looking through, I know since my reference triangle would be 60 or pi over 3, my 5 pi over 3 is 300 degrees. Are we doing okay? Now, I was only supposed to be answering, and by the way, my reference triangle we were talking about is pi over 3, and that's the same as 60 degrees. And I've got 5 pi over 3 up here, and now I'm supposed to find the tangent. Tangent is going to be y over x. Remember, it's sine over cosine. Where my sine value is divided by my cosine value is really comes down to it's my y over x, opposite over adjacent. So my opposite is negative square root of 3. My adjacent is 1. So I should be getting just the negative square root of 3. Are you okay with the reference triangle? It's okay to ask questions. Wheels of the bus come off. I want those questions. I'll repeat your questions so people can hear it. Why is it negative? Why is the negative square root of 3 negative? Let me ask this question. If I were to graph just something over here, okay, let's pretend it's 1, 2, 3, 1, 2, 3, 4. If this is 3 to the right and 4 down, how would I represent that as a coordinate pair? Do you know what I'm getting at? That this would be the coordinates 3 and negative 4. That negative 4 tells me I'm going down that far. Okay. This negative square root of 3, is this telling me I'm going down that far from the axis to this point here? Because this is my triangle. I have my original triangle 2, 1, and 3, square root of 3. I have the 60 degree in the corner, so I flipped it around to be there. And this length going down to this point is negative square root of 3. It tells me direction, where its location there. Does that help? Okay, and once I set that up, I'm able to talk about my tangent value of 300 degrees. And that's different than my tangent value of 60 degrees, which is different than my tangent value of 120 degrees and my tangent value of 240 degrees. because those are all square root of pi over 3 tangents. Okay, if I'm talking about that, and I want to make sure that there is a difference because of the quadrants I'm in and how the sign of that will be. Okay. Any other clarification points? We're doing okay? And like today, I have some people made the mention, hey, it seems really easy when we're doing it in class, but when I do it on my own, so let's do it on our own in class and see what happens. Okay. You got a secant. Okay. It's not just a blind guy with bad English skills. It's 1 over cosine. Okay. So you got to be thinking about that relationship when you're thinking about it. Okay. So I want you guys to take negative 3 pi over 4. And by the way, that's negative 3 pi over 4. So you got to go around the other way, see how you do. 3 pi over 4. Remember, count it in quarters if you need to, but just to help. And I'm going to go positive 3 pi over 4, just so I don't take it away from you. This is 0, pi over 4, 2 pi over 4, 3 pi over 4 is right there. So this is, if I talk about this right here, 3 pi over 4. Now you're trying to do the negative version of that. Okay, so just transpose it and see how you do. Okay, and by the way, 3 pi over 4 is 135 degrees. Okay, so you have a reference triangle, hopefully of 45. You okay with the reference triangle? Or at least drawing negative 3 pi over 4, so you're going to start here. You're going to go 1 pi over 4, 2 pi over 4. 3 pi over 4 should be down here. Okay. Okay, so I've got this going on. I've got my negative 3 pi over 4. I should be down in here with my 45 degrees and happy as a lark, I hope. I changed the type of triangle I'm using because I'm using a 45-45-90 triangle. And remember, in a 45-45, we learned in geometry, remember, that I had x, x, x to the square root of 2. Well, this ratio, if I'm thinking about it, x's drop, and it is 1, 1, square root of 2, and that's what I'm using. Where this triangle is a 45-45-90. Okay, the relation of the ratio is the same. Okay, I just oriented the triangle so I had a 45 degree between my x-axis and my terminal ray. Okay, and remember the triangle's got to hang off of or be attached to the x-axis to make it work. Does that make sense? Now, are there any questions why I have -1, -1 to get to this point right here in my reference triangle? Does it make sense, the orientation, to be in the third quadrant, x and y would both have to be negative? Okay, once you make that determination, finding your tangent is quite quick. Okay, or excuse me, tangent, your secant is quite quick because I'm looking at a secant which is 1 over cosine. Cosine is adjacent to hypotenuse. Secant is the inverse of the reciprocal of that. So I should be talking about the negative square root of 2. Okay. And finally, I think I put it down here. Negative square root of 2. Are you okay with that negative square root of 2? Now, I got negative 3 pi over 4 is the same as negative 135. Okay. So you have that idea, but also the reference angle we talked about, it's going to be 45 degrees, which is pi over 4. Okay. The transfer to that. Be okay with pi over 4 versus 45 degrees? Are there any questions on the reference triangle in the connection of pi over 4s or 45s? Or anything to that point? Now, angles whose terminal sides lie along one of the coordinate axes is called the quadrantal angles. For these angles, we cannot produce reference triangles. Okay? But there are ways we can find things. But it's easy to pick a point P along one of the axes. Okay? To be able to get that going. I was supposed to start here on day 2. Right now, I have this going on. I don't know what that is for. Let's get rid of that. I'm looking at the sine of negative 270, okay? And for each of the following, if it exists, if the value is undefined, write undefined. Well, so we're going to find the value. Sine of negative 270, okay? It's your turn again. You're finding a reference triangle. Go ahead. Find a reference triangle. Oh gosh, it's 270, it's 30, right? Let's talk about a few things for a second. Let's cut up the quadrantals first. I'll put that over here. If I talk about the quadrantals, and that's not really a great picture, hopefully. Nope, it's not going to go. So, if I'm talking about 0 or 2 pi, those are quadrantal angles. Or 0 and 360, still quadrantal on that right side. My coordinates there are 1, 0. My coordinates there are 1, 0. If I can pull that out, we'll rewrite it. 1, 0. To get here, if my radius of this circle is 1, let's pretend my circle's perfect. Okay? I know. You guys really got to use your imagination for that one. But how would I get to this point? If my radius is 1, what's my coordinates of the green dot? 0, 1. Okay, so I got 0, 1. So over here I've got pi. What are the coordinates of my blue dot? Negative 1, 0. Right here, maybe I should use black. What are the coordinates of my black dot? 0, negative 1. You okay with that? So I got 0, negative 1. And by the way, that's negative. That's 3 pi over 2. That's 1, 2, 3 pi's over 2. Okay, are you all right with that? Are you okay with the coordinates that we've been working with so far? Now I'm going to let you in on a secret about coordinates. And we did this yesterday. When r is 1, your sine is y. Your cosine is x when r is 1. We did that yesterday. When, hey, you know, y over r, x over r, and sine is y over r. Well, when your r is 1, your sine is your y value, your cosine is your x value. Does that make sense? Questions about it all? I'm about to use what I just did. Because they're quadrantal, and this is 0, 1 to get there. If I go negative 270 and I'm asked for sine, what's my y value there? It's 1. And we learned that sine was our y over r, right? R here is 1 because it's the unit circle. My sine is 1 to get there. It's opposite over, so it's just to be 1. My value is 1. Does that make sense? Yes or no? Okay, we're just talking about the quadrantal coordinates. Yes or no, Grace? I've lost you. Okay. Are you okay where pi over 2 is 0, 1? Are you okay that sine is my y value at that point? If I'm doing the sine of 90, the sine of 270, the sine of 360, I should be able to find them based on these positions. All for sine. Sine of 0 is 0. Sine of pi is still 0. Sine of 90 is 1. Sine of 270 is negative 1. And that's what I'm just reading from there. If I did cosine of 0, it would be 1. The cosine of 90 is 0. The cosine of 180 is negative 1. And the cosine of 270 is 0. And I'm just reading my coordinates that are on my quadrantals. And more importantly, if you put those in your calculator, it'll return the same value. That's why it's important to be able to do it without a calculator. Okay? So they're asking me, can you? I say, yep, it is. It's 1. So let's look at this next one because I've made this all tangent of 3 pi. Now, I've got some people, okay, Bloom, you just pulled that out. You're talking to angles, and now you're pulling out a radian. 1 pi is 180. 2 pi is 360. 3 pi is the same as 180. I'm over here at 180. Tangent is sine over cosine. Okay? Well, what's 0 over negative 1? 0 divided by any number other than 0 is just 0, right? So it should be a 0 value. So this apparently is the right answer. Are you okay with what I'm doing? Because when we did tangent, it was sine, which was y yesterday. The tangent of 3 pi was y over x. Well, my y is 0 there, and my x is negative 1. So if I go 0 over negative 1, my answer is just 0. Now I've got the tangent of 3 pi is the same as 180. You know, yx. Well, I did that. So that's where it is. I thought I had something else there. Are we okay with this so far? Cosine is my x value of my coordinates. Sine is my y value of my coordinates when I'm working with a unit circle whose radius is 1. Secant, 11 pi over 2. Okay, I'm going around 2 and 3/4 times, 2 and 3/2, or whatever when we do this. So let's look at what we've got. I'm looking at this going around right there. Remember, that's 4 pi over 4. One rotation is 4 pi over 4. 2 rotations, 8 pi over 4. Okay? Now I've got 3 pi. I've got 8 pi over 4, so I got 3/4 of a rotation left. Okay? Which is 11 pi over 2. Remember, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm down here at 3 pi over 2 to finish out my angle. That is 11 pi over 2. Does that make sense or not? Just to emphasize this again. Remember, pi over 2. This is 2 pi over 2. 3 pi over 2, 4 pi over 2. Okay? One rotation, that's 4 pi over 2. 2 rotations, 8 pi. 9, 10, 11 pi over 2. So I'm going to go around 2 3/4 rotations. I'm going to be right here. That's the angle we're working with. It's a quadrantal angle. I can't make a reference triangle with it. But I do know to get there, I got to go 0, negative 1. Are you okay with that? Now, because it's secant, which is 1 over sine, my sine is negative 1. Or 0, excuse me. But if I do secant, does it exist? Can I do the inverse of a 0? Reciprocal of 0. So, because of that, does not exist. Are we okay with that? Yes or no? What? Yeah, no problem. I mean, are you talking about how I know it's the quadrantal angle? Okay. Since this is 1 pi over 2, I've got 2 pi over 2, 3 pi over 2. 4 pi over 2 is one full revolution. Because 4 pi over 2 is 2 pi. Okay? Okay. But we're okay with 11 pi over 2, and this is our spot. Well, think about it. If I'm talking about cosine of, in this case, we're going to use the coterminal angle 3 pi over 2. The cosine of 3 pi over 2 is equal to 0. Are you in agreement with that? Cosine and x are the same in my coordinates. Okay? Well, cosine is related to secant because secant is 1 over cosine. So if I was going to say, well, okay, that's the same as 1 over cosine, like this, and that's 3 pi over 2, 1 over 0, can I do that? And I can't, that's why it does not exist. We're doing okay. I don't want to have something happen today that it was a miracle. Then we go on. Now, we talked about what's happening with our sine. Oh, no idea what that's going on. Check out what's going on in this when we're looking at this quadrant all set up with our values of sine, cosine, and tangent. okay? Now remember, in the first quadrant, all my coordinates are positive. Bless you, okay? In my first quadrant, all my coordinates are positive, okay? Sine is above the line because it's all my y values. I'm not sure why it's not drawing right now. There it is. Sine is all my positive values in quadrants 1 and quadrant 2. So everything above the x-axis is going to be positive, right? To go away from the x-axis. Well, that's all my sine values. Those are positive, okay? My cosines, and let's stay with sine for a second. Sines in quadrants 3 and 4 are negative. Does that make sense? Because they're below the x-axis. They go down, so they'd have to be negative values. Remember, that's my y value. If I'm talking about cosine, cosines in quadrant 1 and 2, cosines in quadrant, not 1 and 2, 1 and 4, are positive because I'm going out from the axis to the right, okay? Cosines in quadrants 2 and 3 have to be negative because I'm going to the left, this way. Are you okay with that? Okay, my last thing. What's a positive divided by a positive? Positive, right? What's a negative divided by a negative? Positive. And the reason why I'm talking about that is, I'm going to get the blue. This is my blue. My tangents are when both sine and cosine have the same value, when they're positive. Okay? When sine and cosine have different values, my tangents are negative. Okay, that's in quadrants 2 and 4, they're negative. In quadrants 1 and 3, they're positive. Does that make sense? So I'm looking at the signs themselves. And why? Okay, because remember, the x value is considered your cosine value when you're working with the unit circle. The y value is considered your sine value when you're working with the unit circle. Okay, and your tangent is your sine divided by your cosine value. Your y divided by your x. And then those other three are the reciprocals of those three values. That's why I'm so concerned about sine, cosine, and tangent. We're doing all right with that. Okay. How is this going to face up on stuff? I like these problems because they're fun to do. When you first learn these problems, you hate these problems. Okay? I'm going to be honest. But let's talk about it as we go through. According to what we just did, I have a reference triangle set up. Okay? Are you okay that I can set up a reference triangle right now? And right now I know my y value is 3 and my hypotenuse is 7. How did I find that? Remember, my y value over my hypotenuse, or my r value, my radius. Okay, that's what we've been doing this whole time so far. Okay, now keep in mind, that's descriptive. That gives me information because I have two sides of a right triangle, and one of them's the hypotenuse. What's 7 squared? 49 minus 3 squared, which is 9. 49 minus 9 is 40, right? So I have the square root of 40 of my x value. But now, do I have any other information based on that? I mean, I'm not going to read beyond that for a second. Let's just talk about what I've got. Right now, I have these possible reference triangles. Are you in agreement that those are the possible reference triangles I could come up with based on just that information? There's 4 possible places I could be worried about. I also know that this is the square root of 40. Okay, are you okay with how we found that? Yes or no? Now I've got to ask. Okay, this might be frustrating right now. Those are I got 4 possible places to work with it until I get the tangent of theta is less than 0. Where's the tangent less than 0? Okay, so I've got the tangent is less than 0 here in this quadrant, and the tangent's less than 0 in this quadrant. Because the tangent's negative, correct? Are we doing okay so far? Now, I got one other thing. Are we okay with the tangent being negative in those two spots? Be positive in these two spots. I've got one last thing to narrow down which reference triangle we should be using. What was my sine value? Positive or negative? So where is sine positive? You okay? It's above the x-axis. So based on the information I got from this problem, I went from 4 possible reference triangles because I had a 3 and a 7, and I had this, and this should be a negative, by the way, negative square root of 40. I found out that tangent theta is negative. Well, I know tangent theta is negative when sine and cosine have different signs. Okay? I further know that when I'm looking at this, I had a positive sine value. Well, sine's negative over here, so I'm not going to worry about this one. I'm not worrying about this one. I'm not worrying about this one. That's the triangle I'm going to use because that's the area they want me to find my theta. Okay, does it make sense? How I narrowed it down. Any follow-up questions about it? Okay, now, based on the information provided, remember, after you do that square root thing, you find your missing side, you gotta be thinking, x has to be negative to get out here to this spot. That's why it's negative square root of 40. Okay? Now, cosine of theta. Remember, this is theta right there. Okay? When I'm looking at that. Because I'm working with a reference triangle. It's going to be the same. So we got x is negative square root of 40. R is 7. Okay? Are you okay with what I've done? Okay? Tangent. Remember? Opposite over hypotenuse. Maybe, but it's 3 over negative square root of 40, or negative 3 to the square root of 40. Okay? Are you okay with that? Now, I'm not going to make them pretty. I'm not going to care about it. I'm just going to care that you know that that's how we got stuff. Are you all right? Okay? We have a secant theta on this one in 7. A secant theta. I want you to hypothesize where everything should be. I want you to give it a try. Remember, secant's 1 over sine. So I'm saying it's not really 3 for, not 1 over sine, 1 over cosine. So cosine theta is 1 over 3, right? 3 being my radius, 1 being the opposite side, the adjacent side, right? Can you find the rest of it? Can you figure out where everything's located? Give it a try right now. We got 5 minutes to try or 2 minutes to try to see what's going on as we work through this. You guys are making the same type of triangle I made in A for B. Give it a try. I always find that once you start doing it in your own, it makes better sense later. Okay? Give it a try. By the way, I know these things. I didn't even notice that I put those in there. So I know that this is the same, and I know that this is that. So now I should be looking at something that's like that right now. I know secant is positive. I know cosine is positive. Okay? But sine is also positive. That's what puts it in quadrant 1. Does that make sense? Cosine being positive, it's either 1 or 4. Sine being positive, it's in 1. Does that make sense? Sine is positive, it's away from the axis, up. Cosine being positive is to the right of the y-axis. So that's where my triangle should be located. Are you okay with that decision? Any clarification or wonders about anywhere else for that matter? Keep in mind my symptoms of what's going on in the problem. I know cosine's positive. I know sine's positive. Has to be in quadrant 1. Okay? So now, I know further that I've got a radius of or a hypotenuse of 3 and an adjacent side of 1. Are you okay with that decision? Because cosine is adjacent over a hypotenuse. Okay? Now, my next thing is to find that green vertical line, my opposite value. Okay? And I just do it, so 3 squared, it's 9, minus 1 squared, okay, is 8. So I got the square root of 8. And I'm not going to try to do anything fancy. I know it's 2 to the square root of 2. I'm just going to leave it as square root of 8. Okay? Because I'm more concerned with you guys understanding where all my numbers are coming from and what's happening with it. Are you okay with the fact I just did that Pythagorean theorem in my head? Okay? So I've got that, and I had to go through that. But now they ask me to find cosine and tangent. Cosine is 1, r is 3, okay? And I kind of knew cosine before I even started, okay? But then I use tangent. That's going to be my y over my x is opposite over adjacent. So that's just the square root of 8. Or 2 to the square root of 2, now I can make that pretty. Are you okay with me being able to see these symptoms? It's quiet. It's scary when it's quiet. There's only 2 things. You're either getting it or you just don't know where to start with a question. So does it feel confident enough to be able to try another one on your own? Let's try C. You guys go ahead, give C a try. Give C a try. Cotangent theta is undefined. So what's that mean? If tangent's 0. If cotangent is undefined, we tried to divide by 0. Okay? So tangent's got to be 0. Okay? That's a symptom. And remember, tangent is sine over cosine, which is y over x. Okay? So I'm wondering, what area is a y 0? Because when I flip it, it's undefined. Are you okay that this is a quadrantal angle? Okay? Because y is 0. It has to be on an axis. Bless you. X is negative, so it's got to be, and we know that secant's negative, so that means cosine's negative, so it's got to be right here. Sitting right there. Those are the 2 possible ways, well, 2 possible spots I got. I've got either 1, 0 or negative 1, 0 as my answers. Okay? The thing that leads me to my negative 1, 0 for the coordinates I'm working with is the fact that secant is negative, which means cosine is negative, because they're reciprocals of each other. And because cotangent's undefined, it had to be the quadrantal right here on the axis, because y doesn't go up nor does it go down, so y is 0. So if those are my values, and now I got to keep in mind, I'm thinking about my cosine, it's got to be negative 1 if I'm using the unit circle. And that's where I'm going with that. My tangent's got to be 0 as I'm talking about that, because cotangent was undefined. Does that make sense? Now remember, we use properties to lead us to this, okay? Being that super sleuth detective that we are. we're going to wrap around to this next thing. No, I think I'm going to stop it right there for today. Okay, we're going to see where things are going. Are there any follow-ups of something that I did in notes today that seemed really, gosh, boom, that was like a miracle you did today? Okay, did it clarify some of the things you're doing at home on the assignments? Yeah, it's actually a quadrantial. It's right here. And our answers are supposed to be those two. They asked me to find tangent and cotangent. Okay, does that help? Okay. Now, that'll be end of today.